Guys, let's look at this problem right here. Here we have a ring of charge and the charge is provided plus 4 microcoulomb and the distance, the point of interest is z, that is at 10 centimeter from the center, and the radius of this circle, this ring, is given by 2 centimeter. Okay, so these are the information available. Now let's look at the first question. First question is asking what is the linear charge density. To calculate linear charge density, we use this equation. Lambda is the term for linear charge density, that is equivalent to Q over L. Okay, Q is the charge provided, that is 4 times 10 to the power of minus 6. But for a circle, the length here, the length of charge, that's going to be the circle, right? And for a circle, it's going to be circumference is going to be the length, and circumference is 2 pi r. In our case, this is 2 pi capital R, and that's provided. So we can directly plug that one. 2 pi times r is going to be 2 centimeter, 2 times 10 to the power of minus 2 if you convert this one into meter, and if you calculate this one, you will get 3.18 10 to the power of minus 5 coulombs per meter. Okay, this is the first part. Now let's look at the B part. The B part is asking what is the electric field caused by the ring of charge. Now to calculate electric field, we use this equation. E is equal to 1 over 4 pi epsilon naught, or K, whatever the value you want. Like K is much easier because K is 9 times 10 to the power of 9. We know that already, right? And also 1 over 4 pi epsilon naught, that's 8.99, same as 9. Okay, so we can put K Q Z divided by Z square plus R square power 3 by 2. And if you want to know how did we derive this equation, you can look at my previous video. I have explained how did we start from the beginning. I explained like how we start and create this equation. Okay, so you can look at that one, and this is the equation we are going to use. Now let's go ahead and plug the values. This is going to be 9 times 10 to the power of 9, and the charge provided is 4 microcoulomb, so this is going to be 4 times 10 to the power of minus 6, and then Z value is 10 times 10 to the power of minus 2, and in the denominator we have Z square, that's going to be 10 times 10 to the power of minus 2 square, plus we have R square, R is 2, so 2 times 10 to the power of minus 2 square whole power 3 by 2. And if you calculate this one, you are going to get, okay, let me see, I have a calculator, let me calculate. Okay, here we have 9, 4, 10, 9 times 4 times 10, that's equivalent to 360, and minus 6 minus 2, that's going to be minus 8. So we are going to minus 8 plus 9, that's going to be just plus 1, right? So plus 1 means 3600. Then in the denominator we are going to have 10 times 100 times 10 to the power of minus 4, plus here we are going to have 4 times 10 to the power of minus 4, 4 times 10 to the power of minus 4 power by 3 by 2, and then we are going to add these two together. Let's see what we get. 3600, and then here we have 100 times 10 to the power of minus 4, that's going to be 0.01, and here we have 4 times 10 to the power of minus 4, that's going to be 0, 0, 0, 0.0004, right? 04, and then that is powered by 3 by 2. Okay, let's calculate this one. Let me plug this one in calculator and let's see what we get. So 3600, let me make sure 4 divided by 10,000. Okay, we got that one right. Now let's calculate this one. 3600 divided by 0.01 plus 0.0004 powered by 1.5, right? 3 by 2, 1.5. So that's going to give us 3,000, actually 300,000, 3 million 3,309,000 94,317.724 Newton per Coulomb. So this is the electric field we are getting. Okay, now let's go to the next part. The next part is asking what is the electric field at the center of the circle. And if you look at the center, in the center we are going to have this electric field repelling each other. We have x component, y component. It's going to repel each other, and it's going to be equal in magnitude everywhere, right? So it's going to be 0 because it's going to cancel each other. So we are going to have 0. So for C part, the electric field is equal to 0. Now let's look at the D part. What happens if the z is very large? If this z distance, if it's very large, let's see what happens. If you, this is E is equal to, now let's go to the D part. In the D part, if we bring this equation right here, let's write this equation again. E is equal to kq z over z square plus r square power 3 by 2. Okay, if the z is very large, we can neglect this r square, right? Because it's going to be, compared to z, it's going to be very small value. So we are just going to have z square in the denominator. So we are going to have kqz over z square powered by 3 by 2. From this one you can see 2 cancels. We are, and okay, c square by 3 by 2, yeah, 2 cancels, and we are left with z cube and kqz over z cube, and this cube and this one cancel. This is going to become square. So from this one you can see this is going to be a very large number, and that's divide this one. So this is going to be approaching 0. So the electric field will be approaching 0 if it's very large. And that's how we do this kind of problems. I hope this helps. Thanks for watching.